Today we are going to demonstrate a field test method for measurement of total oxidant in water systems treated with chlorine dioxide. This is a titration method, and the reference code for this method sheet, should you need to request it, is FTM035A. We recommend this test wherever water is treated continuously with chlorine dioxide, including water used for drinking or cooking purposes, the limit being 0.5 mg per litre of total oxidant for drinking water in the UK, as of April 2020. This test is not a replacement for laboratory testing where it is required for regulatory purposes, for example on private water supplies. However, because of the low stability of chlorine dioxide in transported samples, field tests like this one for total oxidant will provide valuable information at the point of use that cannot be obtained through delayed laboratory testing. This method will detect most common oxidants associated with chlorine dioxide generation, namely chlorine dioxide, chlorite and chlorine. However, it doesn't detect chlorate, for which there is no reliable field test method. Chlorate does not normally represent a significant proportion of total oxidant levels detected in systems treated with well-run chlorine dioxide units. You would expect to find mostly chlorine dioxide or its primary byproduct of disinfection, chlorite. In some systems, chlorine may also be present. Note, this test is not capable of identifying and quantifying these species individually. The result represents detectable oxidants in the sample as an equivalent concentration of chlorine dioxide. We generally recommend that you should use this method in conjunction with one of the methods for free chlorine dioxide. Activ-Ox test kits are supplied as standard with a free chlorine dioxide test, including chlorine dioxide VLR reagent. Contact your feedwater rep if you need guidance on test selection or interpretation of results. Before demonstrating the test, we would like to talk quickly about sampling. It is important to remember that chlorine dioxide is a gas and can easily be lost from water samples through agitation. So don't sample from outlets that spray the water into your container. Take the sample with minimal agitation. We recommend that you should fill your sample container until the tap end is submerged and then continue to overflow the container for several volumes. This can minimise the loss of gas caused by splashing. You should also cool if necessary, as high temperatures interfere with the test. To cool, fill a clean sample bottle to the brim, cap it securely, and then run cold water over the outer surface for a minute or two. Filling to the brim and capping the sample will prevent the loss of chlorine dioxide to atmosphere before testing. Sample bottles used for this test should not be treated with thiosulfate, as this will neutralise any oxidants present. For this test, you will need the following reagents: Activ-Ox titrant, 0.3 gram potassium iodide tablets, 50% sulfuric acid, and Activ-Ox indicator powder. For most applications, we expect the range to be 0.25 to 1 mg per litre of total oxidant, so we would recommend using a 50 ml sample volume. If you're expecting higher or lower results than this, you may wish to opt for an alternative sample volume as shown. In this example, we'll be using a 50 ml sample volume. First, take the required volume of your sample and add 1 potassium iodide tablet and swirl for 10 seconds. Do not shake. It is not essential that the tablet is fully dissolved. Add 5 drops of 50% sulfuric acid. Add a small amount of Activ-Ox indicator powder. If oxidant is present and the sample is not too hot, the sample will go a blue-black colour. Add 1 drop of Activ-Ox titrant at a time to the sample, making sure you count the number of drops and swirl until the blue-black colour disappears, leaving a colourless solution. The total oxidant is calculated by multiplying the number of drops by the factor based on the table shown. For example, 20 drops of Activ-Ox titrant times by a 0.05 factor equals 1 ppm as chlorine dioxide.